Okay, thank you guys. First of all, these guys are just not there. I wanted to really applaud them. So I don't know if you guys realize how hard it is to get up in front of your peers and tell them about how you're going against the trend and doing something different to kind of figure out a better way to do things that have been done that way for a long, long time. So I'd really like to applaud them. So I thought about this quote here, listening to them speak. You know, a man who carries a cat by the tail learns something he can learn in no other way. And that's exactly what these guys are doing out there. We can go to these conferences and we can talk about all these ideas, but until they can get out there and actually try it, you're not going to learn anything. So I don't know what they do in Bismarck, because their cats don't have tails. So I was out there in Winoka and they got a cat running around with no tail at all, so I kind of thought about that. So I don't know, I was trying to hook this up, I didn't hear the introduction real well, but we do specialty potatoes. That means we don't really grow russet potatoes. We like doing things a little different. Pretty much every aspect of what we're doing is a little different. So even the potatoes we raise are a lot different. So you've seen that picture. We do a lot of different colored potatoes, reds, yellows, purples, and we were actually the first guys in the country to bring fingerling potatoes into the country. It's not a real good idea to tell us that we can't do something, because that's pretty much a guarantee that we're going to find a way to get it done. A lot of people fought us on bringing those in, and now they're real popular. I don't know if you guys are real familiar with them up here in Montana. They didn't hardly know what they were. We do fresh market potatoes. We have our own packing shed, and then we also do certified seed as well, so some diversity right there. We are on a 2-year rotation, which means half of our acres each year are potatoes. The other half we're doing a multi-species breeding manure crop right now. I'm going to get into a lot of detail on that one here in just a little bit. And we are center pivot irrigation. Our elevation is about 7,600 feet, and technically we are desert. Our annual precip is 6 inches. Usually, the last several years it's been more like 4. So one thing that's nice is we've got a bunch of mountains to the west of us. We get good snowfall there. It melts, runs off in spring, fills the aquifer underneath us. Unfortunately, we've been in a pretty severe drought. We're not even getting the snow lately, so a lot of our motivation for our soil health practices are centered around water consumption. So we'll talk about that. Now, we keep talking about the social aspect of things. You know, we got kind of this new generation coming up, kind of relearning things. Fortunately for me, I was always surrounded by a lot of teachers, and we always have believed strongly in soil health. What we've got up here is a picture of my grandpa, my grandma. I've got my dad, uncle, and aunt right there in the front. And I, just growing up as a kid, I just heard this over and over and over again from my dad and uncle about how grandpa always said, you got to take care of the soil before the soil can take care of you. Then, just like every other farm in the valley there, we fell into the same ruts and the same traps as everybody else, and we got hung up in conventional agriculture. We were using the chemicals and the fertilizers. I remember very clearly having a conversation with my uncle out by the old potato storage there. And he said, Brendan, we're going to start making some changes around here. We're going to get away from the chemicals and the fertilizers. And I didn't understand why. So why is it that they're working? He said, no. He said, you know, like you said, Grandpa always said, we got to take care of that soil. He said, something happened along the way. We quit doing that. We're not taking care of the soil anymore. And he felt strongly that we needed to do that. This was about 20 years ago, and at the time, we just couldn't find the support. You know, these guys talk about the lack of local support. I understand that 1,000%. It was really tough. We were real fortunate to have Woody here about 20 years ago, and we've learned along the way to really start building the soil again. So I've got just a few slides here to share before we really get into it. But I just wanted to kind of warn you that the crop I grew this year is probably one of the worst potato crops I've ever grown in my life. You guys are probably wondering, why did we bring in this guy? He doesn't even know what he's doing. But weather can be a huge factor, so I'm dedicating these next 4 slides to Gail Fuller. He gives a great presentation. Well, basically the premise is Mother Nature always wins. She got the better of us this year. So here's a picture that was taken right at potato plant time. We got lots of rain, lots of snow, really cool soil temps, really got us off to a slow start. Finally got all that to melt off, finally got things going, and then we had a major forest fire hit us this year. So what you can see here is we've got the San Luis Valley here. You can see all the circles there from the center pivot irrigation. This is where our watershed comes. But our farm is right in here. So we had this forest fire that got started here, and the smoke came across the valley, and that, since we're in this valley, we've got mountains all around us, that smoke just settled in and blocked out the sun. Somewhere between 2 and 3 weeks it took before we could really see the sun, and this was after the potatoes had already emerged. So it resulted in some pretty fascinating sunsets, but the trouble is it really stalled out that crop. I don't care how healthy your soil is, how much organic matter you got. If you don't have sunshine, there's not much you can do. I've yet to find a substitute for sunshine. So this factor really slowed us down. So we finally, they got the forest fire under control, finally got the smoke to blow out of there. We were feeling pretty good again as the plants were finally growing. But we were still in the middle of a drought, so we kept praying for rain, and we got our answer. So there's a lesson to be learned here. When you pray for rain, be very specific. We need rain, not hail. We got just pounded with a hailstorm, almost completely wiped out a half circle of potatoes here. Like I mentioned, our annual precip had been about 4 inches annually. We got 1 3/4 inches with this storm alone. Worst devastation I've ever seen from a hail crop in our area. So, you know, it's just one of those things. So here's a picture from back when we used to grow good potatoes, years before. So that's a picture of some purple Vikings there. So that's what I really want to focus on here. And I don't know, there's probably not a whole lot of potato growers here, and I'm going to really focus this presentation on potato production, and that's okay. Because what I'm going to talk about, we're talking about concepts, we're talking about principles today. No matter what your crop is, you can substitute it in here, and the concepts still apply. But for my case, I'm going to focus on potatoes, because that's what I know and understand. So there's a lot of factors that surround this potato crop. You know, there's a lot of pest and disease pressure, water, fertility, all these issues. And I don't think anybody's out there is going to argue that these factors can all have a direct impact on the crop itself. What I really want to focus on today is how we approach these problems. The problems I see in conventional agriculture today is we have a very linear approach to solving these problems. And for example, if you have insects out there, the insects are bad, we must kill them, remove. And if you look at all the solutions to these problems out there, there's a reoccurring theme that occurs here. You see side come up very often. And side means to kill and to remove. So people around our area, they see how we're growing potatoes, and most of them assume that we're organic. Now, I'm here to tell you right now, we are not certified organic. I just really don't want to pay the government to come in and start telling me how to do things. So they say, well, you're not conventional, you're not organic, what in the world are you? So I came up with a term that I feel closely defines what we're trying to do. I used to tell people we were holistic. A lot of people look at you funny when we use that word. It's a misunderstood word. It's a great word. So even when I went to define biotic farming, I still had to use that word holistic. And what holistic means is looking at all the individual pieces and how they fit into the whole. And that's very important. So biotic farming is what I consider what we do. And what that means is looking at all of the living components of the complete system, both the living and the non-living things, because the non-living components have an impact on the living parts. So life is a really strong reoccurring theme here. So the other thing that works really nice about using the term biotic is once you identify the term biotic farming, you have 2 directions you can go, right? Either you're going to be antibiotic or probiotic. And that's what I like about these terms, because you can even give this talk to consumers and they get what you're talking about. They have no idea how it applies in agriculture. So what we're going to do first is take a look at the antibiotic approach and see what happens when we start removing life from the system. Now the trouble with the antibiotic approach is, you know, it's a very linear thought process, but the trouble is there's a lot of different factors in here that it doesn't take into consideration. So what we're going to do is kind of dissect this a little and take a little closer look and see how all these pieces work together. So pest pressures are a really easy one to kind of look at, and we're certified seed growers, and there's viruses that we have to deal with in potatoes, and they get vectored through green peach aphid. So if an aphid feeds off a plant with a virus, goes and feeds on a healthy one, it can transmit that virus. So the certified seed growers in our area use a lot of insecticide. That insect's causing a problem, so our approach is, well, we got to kill it and remove it. But the trouble with that is insecticides are going out there and killing insects in the field. There's a lot of good insects out there too. And the trouble is we're killing off them, and a lot of those are out there actually feeding off the aphid for us. So we kind of, you know, it's removing that balance. So you talk to a lot of these guys and say, well, that's fine, they have this new insecticide out. It doesn't kill the predators, it's only going to kill the pests. Well, that's great, but now you just remove the food source from my predators. You think they're going to stick around? So now you have this situation where you go in with the insecticides, you wipe everything clean. You've got 2 different populations out there. You got one that lives off the plant and one that lives off of those insects. Which one's going to come back first? The one that's feeding on the plant. So now we've created this opportunity for an epidemic. Now we're more vulnerable. So what's our approach? Well, now I need another application insecticide. Then you need more and more and more, higher rates as you keep going along. I think it's pretty easy to see how that relationship is disturbed there, but we also need to keep in mind what other damage are we doing with these insecticides. There's a lot of beetles, things going on up in the ground, above the ground, that are really beneficial to the complete system, but we're killing them off as well. Now, fungicides and soil fumigants, I think, are two of the most damaging things we've done in agriculture, especially in potato production. Once again, it's a very linear approach. You know, there's certain diseases that are really damaging to potato crops, so our thought process is, well, if that fungi is out there causing damage to the crop, we must go out there and kill it. So early blight, you know, is a foliar disease that causes a lot of impact to potato crops. We go out with these fungicides every 10 days just to make sure we're on top of it, kill and try and remove all this life from the system. But once again, these fungicides, a lot of them are broad spectrum, so they're not only attacking the pest that's causing problem out there, but it's taking out all the good stuff out there as well. And we've heard this several times today about the life in the soil and the benefits that come along with it. But if our approach is out there to kill and remove it, how are we going to get the benefits from the good guys that are out there? So we're killing off a lot of the fungi that thrive on the plant itself, which in certain populations, they actually control the problem for you. Here we are killing it off when it's part of our defense mechanism. Soil fumigants, there's a lot of life in the soil that we're killing off along with this. And like I said, a lot of that life in the soil was actually doing us a great favor in helping control that disease for us in the first place. Now, parasitic nematodes is another thing that we're seeing a huge problem with back in the San Luis Valley, especially in potato production. And notice that I mentioned parasitic nematodes. I'm being very specific there. There's a lot of nematodes that thrive in the soil, but less than 10% of them are actually parasitic. 90% of them are actually out there doing something good for the complete system. But the trouble is we're focused on the few out there that are doing damage out there. And it's really interesting looking at nematode populations in the valley, and we're seeing a really strong correlation out there. And it seems like the guys that were using the most fumigants and fungicides are the ones having trouble with nematodes now. And that doesn't make any sense at all, right? So here we're talking about a fungicide. It's killing off the fungi in the soil. It has nothing to do with this little worm out in the soil, right? I'm talking about two completely different things. There's no relationship whatsoever. Here's the problem. You see what's going on there? So that worm guy there is the nematode that's causing us the problem. And in a nice healthy soil, there's fungi that live in the soil that actually trap and kill and feed off of these nematodes. But when we're going out there and fumigating the soil, we're wiping all of this fungi out and removing another defense mechanism. So once again, we tried removing life from the system that was giving us trouble, and it's creating other problems down the road. So that's where I'm really talking about coming in and looking at the big picture. So now we have a nematode problem. Granted, it was a problem we created ourselves, and that's one thing I keep seeing coming up over and over again, is every single problem we're dealing with now in agriculture are problems that we've created ourselves. And that's a really hard pill for a lot of guys to swallow, but when you look at this big picture here, there's not a single thing you can mention here where I can't show how we created that problem ourselves. But of course, our approach in conventional agriculture, now we have parasitic nematodes. You want to guess what our approach is for controlling them? Well, we got to kill them now too. Here we have another input, another way of removing life in the soil. And not only are we removing the parasitic nematodes, but we're removing all the good guys out there too that are actually doing us some good. So another way that we're damaging the beneficial soil biology. Now, inorganic fertilizers, another interesting subject. You notice I've got a marked green there. We all know that crops need fertility to grow. NPK, inorganic fertilizers, very soluble, goes right into the plant. We see quick responses to it. It's done great things for agriculture, right? So what could I possibly complain about in NPK fertilizers? Well, they also come with high amounts of salt. So when we apply these fertilizers, we're adding the salt content to our soil. What do you think that's going to do to the life in the soil? Have you ever poured salt on a slug? It doesn't do so hot. That's exactly what we're doing to the life in the soil. It's the same reason we cure a hand. We're adding salt because we don't want the bacteria to thrive on it. And this is what we're doing to our soils. Even in the Bible, they talk about salting the land of your enemies. We're doing it to ourselves. We don't have to worry about our enemies. We're own worst enemy. So now you see there's kind of a central theme there. The beneficial life in the soil is a really important factor. In the trouble in conventional agriculture, all we do is we worry about the plant, right? What are the plant's needs? We don't worry about the soil and these other three components in there. So you've got the life in the soil, you've got carbon, and you've got soil structure. And what's nice, the thing I like about biomass is, you know, we've had these subjects already approached today. Soil structure, aggregation, the exact same thing. Carbon and how it feeds into the soil structure. You see there's a really strong relationship here. You need the life in the soil to create soil structure. Bacteria come in, they have sticky substances, they make your microaggregates. You get that in place, then you get the fungi come in creating macroaggregates out of those. But when you're destroying one, it's destroying the other. If you don't have the life in the soil, you can't create soil structure, and as you remove the soil structure, you have a less of a proper environment for that life to thrive. The carbon is really important with soil structure too, as far as forming those aggregates, and the carbon is the driving force for the life in the soil. So now when you have poor soil structure and no carbon, this can have a great impact on water. It's true of dry land, but it's especially true in irrigation because we're controlling that water and it affects how we do things. Now back before we made the transition, started taking care of our soil, we used to do this to our center pivot every single year. It was just a given. We accepted this fact. This was reality. We were going to bury the center pivot every single year. It was on one of our sandier fields, and we used to blame the soil type for this problem. But what it was actually a problem with our management of that soil. When I started putting this presentation together, I wanted a picture of this to be able to put in here to show as a visual of what's going on here. I wasn't able to go out in my field and take this picture. I had to run over to the neighbor's field to take this picture because we don't have this problem anymore. But it's still the exact same soil type. I mean, it's literally right across the road there. But the trouble is this soil doesn't have any life in it. Since you don't have that life, you don't have that carbon, you don't have that soil structure. And it really goes to show you how valuable the soil structure is. It's amazing how much strength it adds to the soil. It keeps those pore spaces there, allows water to enter the soil easily, and still allows gas exchange, even in a saturated soil. So these are things we need to really keep in mind. You know,
it's a big eye-opener for everybody to see what.
Again, it was another problem we had, but guess who created that problem? It was us. So we need to take some responsibility here. So now you have these tight soils, and it's hard getting water into that soil. So now we have to run the pivot more, because you have to actually overwater in order to get the amount of water down into that root system you need. So now we're overwatering, so now the plants are wet more often. Now you have an environment where disease has a greater opportunity out there. Same with the soil-borne pathogens. Well, a lot of the problems that occur on the potatoes are in soils that are waterlogged and overwatered, and that's a problem because we've created that. Weed pressure can also thrive in soils that are over-irrigated, these tight soils. There's some great charts out there. You know, you can look up a certain weed, and it's always an indicator of what's wrong with your soil. And a lot of the weeds we used to deal with, the species we were dealing with, were all indicators of tight, waterlogged soils, low in organic matter. So there's a couple other factors that go in with the weeds too, like I said, with the soil structure and the carbon. And a lot of times it's an indicator of a fertility imbalance, either an excess or a lack of a certain nutrient. So we have a lot of impact on the weed pressure as well. So now we have a weed pressure created by all these other problems. I think you probably got this thing figured out, and that's what's our approach, going with another side, try to kill it off and remove it. Trouble with this, if you pick the wrong side, wrong herbicide, put it on the wrong time, or just wrong chemical, you can have a direct impact on the potato crop. You can hurt the crop itself. And also we're having trouble with resistant weeds being developed because we're overusing these tools. They have a certain place, there's time and a place to use these, but when we abuse them is when we really start causing these problems. So now there is an alternative to weed control, and that is tillage. And that's actually the only reason we really use tillage is for weed control. We mechanically control the weeds in our potatoes. And this is where I'll vary from the no-till guys just a little bit. You know, I am growing a potato crop. The crop we need is down in the soil. I have yet to figure out a way to no-till grow potatoes. I think you grow them no-till, but you'd never be able to harvest them. So me and Ray, we really butted heads for a while. He said, you got to no-till potatoes, you got to no-till potatoes. A couple months later, I called him up and said, hey Ray, I found a no-till potato harvester. Oh, great. So now I just need a couple of uniforms to pull. So you know, we just got to keep this in mind. So totally understand the concept of no-till. I get what they're after. I think it's great when you're growing a crop that's up above the soil. I think it's fabulous. But in my case, it's just a little bit different. But I know the damage tillage is doing, so when we till, it's always with a purpose. You know, we don't do the recreational tillage. I hate spending time in a tractor. So we only do it for certain reasons, because we understand that tillage can have a huge impact on the carbon in the soil. When you break that up, and we've talked about that quite a bit, so I won't go into that too much, but it also physically destroys that soil structure, those aggregates. The fungi, hyphae, are very fragile and can be easily broken apart. So we don't want to go out there and do tillage just to till, because we're going to set ourselves back here. So this is what I consider the mess we've created for ourselves in conventional agriculture. This is where we were when me and my uncle were having that conversation. It seemed like every time we tried solving one problem by removing life, we were creating two more. And it's this vicious cycle. You create these addictions to them and you don't know how to get off of them. But there is hope, because no matter how bad you screw up a soil by this system, you can always heal a soil. So you can always wipe the slate clean and start over. But you have to kind of start farming with a new goal in mind. And what you want to do, instead of constantly removing the life of the soil, you really got to focus on bringing the life back into the soil. And this can only be done in one way. And what we do is we call these soil primers. This is a term Paul Brown came up with, I believe, and I stole it from him because I really like it. So I ought to start paying the guy royalty or something. But what a soil primer is it's priming your soil for success. And the only way to do that is to bring life back in. So here's how we do it with green manure crops, companion crops. They're both living plants, living roots in the soil. A lot of value there. All of our fertility is carbon-based now. None of them are inorganic. They all have carbon attached to it, so when we plant the soil, they're staying in place. But also that they have to be digested, broken down by the life of the soil before it becomes available to the plant. So now, instead of fertility being an expense for us, now it's an investment. We started investing in our soil, and we greatly reduced our inputs. Then there's some other inoculums and stuff we use in compost, and some fish fries that we use that are all involved with adding carbon and life back to the soil. So like I said, there's the number one component right there. It's about feeding the life in the soil. Not only putting these known populations, bacteria and fungi out there, but the life, the energy, the food source for these guys to thrive and do business. All these are actually adding carbon to the soil too. Carbon-based fertility, fish compost, that one's pretty easy. It's carbon-based and has a carbon to it. The carbon is the driving force behind the life in the soil. Green manure crops have been huge for us in this component too. Now see, we incorporate our green manure, and we used to think, well, that residue being returned to the soil is where all that carbon's coming from. But as you talk to these guys about the CO2, the gas exchange, all this, we're starting to learn more and more that the actual benefit of the carbon going to the soil is through the root exudates. The plant actually exudes carbohydrates into the soil to feed the life of the soil. And that's where the true carbon benefit we're seeing is coming from. So now we still have a really strong relationship between these three factors here. But now instead of one where you're going in and destroying part of it and destroying the other two, now we go through and feed all three of those and actually help each other out. So now as we add the life to the soil, the bacteria and the fungi, it's creating soil structure for us. But as we improve our soil structure, now we have a better place for that stuff to thrive. So the two actually complement each other very well. So now we have the carbon, which is helping out the soil structure, and the carbon is the food source for that life. Now we have good aggregation, good soil structure, we have good carbon, and this has had a huge impact on water too. Now one of the main reasons why we've got away, we used to do potato and grain rotation. Like I mentioned, the drought, we were depleting our aquifers, so one of the main reasons we went away from the barley and went to the green manure rotation was for water savings. Now this was a direct savings, because instead of 20 inches to grow a barley crop, we were using about 6 inches to grow a green manure crop. That was great because we were saving a lot of water each year in making sure that we could farm more years. But the thing that really surprised us is what impact this had on our potato crops the following year. Since we were adding all this life to the soil, we had the soil structure and the carbon out there, it had a huge impact on the water that was being required to grow our potato crop. So what you got here is we got the green line and the blue line there. What it is we've got two full circles there, so it's easy to measure the water usage on them. So this year, that was a potato crop. We had the green manure crop in the rotation. The next year was green manure, so potatoes there. So these bottom dots here is how much water we've been using on our green manure crop. So, very little on some of these. Usually, between 4 up to 7 inches on the green manure crops. That's a huge water savings for us. But what was really surprising is before we had the meters out there to really track this, everything you read on potatoes is absolute least amount of water you can use to grow a potato crop was 16 inches. That's what all the experts told me. What you can see is, with the exception of that 1 year, the most I've ever used is 17.8 inches. And what happened that year is we just had a really abnormal windy spring. So our water use efficiency was very low. If you remove that one anomaly there, you can see 12 to 14 is a pretty good number. I can grow a really good potato crop with 12 to 14 inches. And it's not like I'm sacrificing yield in order to do it. What it's doing is really emphasizing to us how inefficient we were when we didn't have that good, strong, healthy soil to support our system. So you notice the red line up there. Anybody want to guess what that one is supposed to represent? According to the University of Idaho, that's their average water consumption on potatoes in Idaho. But like I said, I think that's a representative of an unhealthy soil. So there's a lot of room for efficiency improvements out there when we start focusing on the soil. So you remember that center pivot out there that we used to bury? This is what our sprinkler tracks look like now. I don't know if the pictures even do it justice. It's really hard to take a picture of that, but you'll notice that I'm sure not burying that sprinkler anymore. So this is the exact same field that we used to have to go out there with our straw bales and get these sprinklers back out of these ruts. But what you see going on now is each year, as we brought more and more life into our soil, more soil structure, we've gone away from those deep ruts. And each year, those ruts got a little shallower, to the point where we were just nice and flat. All it was doing was crushing the potato hill. It was flat. We're to the point now, and a lot of this comes after we brought in the diverse green manure mixes. We're to the point now that at the end of the potato growing season, when we've made probably about 20 irrigations, we aren't even crushing down that potato hill. At the end of the season, that sprinkler is literally climbing over every single hill out there. So just think about that. If the weight of that sprinkler, as heavy as it is, doesn't even crush the soil, just think of how versatile that soil is. Think of how strong that soil is as far as holding that structure together. Now we're holding that structure together instead of collapsing it, with all those particles moving together. So that has that's where our impact is coming as far as our irrigations go. The other thing that's nice about soil structure is even if you have a nice, healthy soil structure, even under saturated conditions, you still have proper gas exchange. In a conventional soil, poor soil structure, when you water it, you push all the oxygen out of there, you create an anaerobic condition where disease can come in and thrive. So by having that structure, we're allowing that gas exchange no matter what the other conditions are. So now we're actually, when we irrigate, we have a high infiltration rate, so when we water, we are able to put less water on per irrigation, but we're also able to put fewer irrigations on per season, because once the water gets where it belongs, we've got the carbon there to hold on to that water. So since we're doing fewer irrigations, we have less time when that foliage is wet, so less opportunities for disease, and same with the diseases that thrive in those anaerobic conditions in the soil as well. We've also seen a huge impact on the weed populations out in our fields. We still have weed pressure out there, but the species that are out there have greatly changed. We used to have a lot of sunflowers out in our fields, and when you look on those charts on sunflowers, once again, tight, waterlogged soils. Now we have pigweed, lamb's quarter, and purslane, about the only 3 weeds we see out there. You look on that same chart, what are these indicators of? It's always a very well-drained soil with high fertility. So the weeds are a great indicator that we're doing things right. The other thing is, too, I don't mind a certain population of weeds out there. We have to keep them under control because you don't want to overwhelm the potato crop, but a few out there is okay. It's creating a little bit of diversity. So we need to keep in mind those weeds are out there to solve the problem for us. They're actually a lot of benefit to weeds, but we need to accept that. So at no part of our management plan now do we ever go out and try to eradicate anything. Our goal always now is to control. And there's a huge difference between eradication and control. Some of the soil primers can also have a huge impact on the foliar disease too. A lot of those known species, bacteria and fungi, when you apply them through the irrigation, you establish these populations on the plant itself. And a lot of these can be inhibitory to a lot of the diseases, either through competitive inhibition or they can be antagonistic too. So we've seen huge impacts there on the foliar disease. And the same is true of the soil-borne pathogens. On our potatoes, we used to get a lot of rhizoctonia. And what this is it's a fungi that lives in the soil, lives on the root system of the potato plant, and when it starts to go to its overwintering stage, it puts a black dot on these potatoes. It can usually be brushed off, but it really affects the marketability of the potatoes. Now everybody else is out there trying to apply a fungicide, trying to kill the rhizoctonia. So what we've done is we've brought so much diverse life into the soil that these diseases don't stand a chance now. We've overwhelmed them with the good guys, the guys that are actually working with the plant. So we've been able to control all of our soil-borne pathogens by bringing more life back into the soil. Our nutrient management has been greatly impacted by bringing the life back in the soil. Back home, if you're asking a guy how much nitrogen does a potato crop need, they usually tell you about 180 pounds of nitrogen per season to grow a potato crop. We're finding that those numbers aren't really true anymore. And the reason that they feel like they have to put 180 pounds out there is because the system is so inefficient that they actually have to over-fertilize it. It's a very leaky system, so you have a lot of inefficiencies there. These inorganic fertilizers are easily leached and they're volatile, so you're losing them all the time. Now when you focus on the green manure crops and the carbon-based fertility inputs, once again, like I said, they're investments in your soil. If you put more out there than the crop needs that year, you're not losing anything at the end of the season. It's still there the next year. So you start to get this accumulative effect by taking this approach. When we were doing our potato grain rotation, we were using a lot of compost, but we had two crops where we were constantly removing a crop from the field, so we had to put it back in some form. So we were putting 3 tons of compost on our field every single acre, every single year. As we started moving forward and got to the green manure crops, we were able to cut that application rate in half. Because the green manure crop, we weren't removing anything, just returning everything back to the soil. So we got to the point where we were 3 tons every other year. We're to the point now that we have the diverse mixes out there with lots of legumes. We're fixing a lot of nitrogen. We have everything else cycling properly. We got to the point where we were applying 1.5 tons every other year. So if you want to start looking at the economics of what's going on here, where I talk about investing in your soil, we've had a huge economic impact. Now we're to the point now where I've actually got one circle that, we pull soil samples every spring and monitor our fertility, just make sure we're not shorting the crop. We've got so much residual fertility built up in our soil now that we're actually going to skip an entire application. So now we're down to 1.5 tons once every 4 years. So, like I said, I think the economic side is very important here, and I haven't really dove into it in this presentation there, but I think there's a lot of valuable information there as far as, the long-term effects of taking care of your soil financially. So parasitic nematodes, that's another problem we started to have when we were conventional, and we've been able to get on top of this problem by bringing in these soil primers. What's really nice about these green manure mixes is there's a lot of flexibility there, and they have very specific mixes that can be geared towards solving this parasitic nematode problems. Bring those in with some of our other soil primers, and we've been able to really help some guys get on top of their parasitic nematode problems. And we're not going in with any type of side, we're not trying to kill anything off, we're bringing in more diverse life, and it's solving these problems for us. See, conventional agriculture, they try avoiding their problems. What we're starting to do now is we're actually starting to solve problems. And like I mentioned with our wheat populations too, the carbon, the fertility being in balance, and some of these other soil primers have really had an impact on our weeds overall. So I won't go into that one too much more. Now the insect pressure has been fun to watch too. Like I said, our goal is no longer to go in there and eradicate the aphid from our field. We're okay with some aphid out there because I feel like every living thing has its place when you look at the big picture, even the pest. But the reason the pests overrun us is because populations are out of balance and we have an unhealthy system. So I'm okay with certain populations of aphid being in my field. But the way we've done that is by really focusing on the predatory insects in our field. So now we have a lot of the different insects out there that are actually feeding off of the aphid for us. So ladybugs were always one we always knew about. We always liked seeing a lot of ladybugs out there. But as time goes on, we start discovering more and more other insects out there that actually can feed off of aphid for us. So there's a whole list. From there to there, it's all different insects that are known for feeding off of aphid in our fields. So we're trying to bring as many of those in as possible. Then you notice the last two on here, those are actually fungi that thrive in potato fields. that actually can feed off of the aphid and control aphid populations for you. But the trouble is, if you're going out there with the fungicide trying to control some other problem, you're killing those off as well. So now we need to create an environment where that stuff can thrive, and they actually are another tool that's available to us to help control these populations. Now, before I went and spoke in Idaho, I had a lady from University of Idaho call me and say, well, that's great what you're doing with the ladybugs, biocontrol on aphid. But she said, we've tried biocontrol of Colorado potato beetle as well. And she said, we've never had any success. So she asked, what do you do about Colorado potato beetle? Well, my answer is, well, we live in Colorado. See, we don't have Colorado potato beetle. So I'd like to know who the punk was that named the Colorado potato beetle. It was interesting because she said, well, there's no predators of Colorado potato beetle. I will agree with that somewhat. There's no predators of the adult Colorado potato beetle, but there are a ton of predators out there that actually feed off of the eggs of the Colorado potato beetle. Another checks and balances system out there. But the conversation I had with her, I asked, well, what was your approach for your biocontrol? She said, oh, we went out there and we released ladybugs into the field, and it didn't do any good. And I'll agree with her. That doesn't do anything. Going out there with just, it's another Band-Aid approach. It's not the complete approach to it. You can't just go out there and release insects and expect them to do their job if you don't have the proper habitat for them. Because see, I used to have the same problem in our greenhouse. Part of the certified seed program, we grow our own tissue culture potatoes. We plant them in a greenhouse and grow them out for mini tuber production. Every summer, I'd get a huge infestation of aphid and thrips in my greenhouse. And we used to use the chemicals, but as we changed our practices out in the field, I wanted to be away from the chemicals in the greenhouse as well. But I would go in, just like she tried with her biocontrol, I would release ladybugs into my greenhouse. They'd be there for about a day, and they would leave. So here's how I started solving my problem. Now when I plant my potatoes, I plant a diverse flowering mix right in the same plots with my potatoes. This flowering mix is known for attracting ladybugs and lacewing. It's actually called the lacewing mix. So now I go through and release my ladybugs, and guess what? They're sticking around. I've got complete life cycles out there now. So I'm releasing adults, but I'm seeing eggs, pupae, larvae, and adults. So now I've got complete life cycles out there. Now that I've got the complete life cycle happening out there, now when a few aphid come into that greenhouse, I've got my defenses set up, and they're actually consuming those aphids before those aphid can establish their population. So now my next goal is to replicate this same thing out in my potato field. I need to get more flowers out in my potato field. See, we have this discussion a lot with the certified seed program. Everybody says, oh, we've got to go out there and we've got to pay for our neighbors to spray their fields with insecticide. Then they all look at me and realize, okay, he's probably going to have a problem. It's fine, man. We'll spend a little bit of money on ladybugs, too. I say, no, don't waste your money on ladybugs. What we should do is be buying flower seed for these guys. The more flowers we can get incorporated out here, it's the only way we're truly going to start controlling these pest populations out there. Another thing I think is real neat is, I don't know if you guys have ever heard of Jack Schultz. He's out of Missouri. He's doing some really great work. And I really recommend going on to YouTube and finding this little 20-minute video here. But what he's starting to discover, he kind of asked the question, how does that predator out in the field know where the pest insect is? And what he's starting to discover is when a pest feeds off of a plant out in the field, that plant actually releases a scent that attracts the predator to that specific plant. How cool is that? But see, this only happens when you have the complete system, when you have all these components in place. So what we really need to do is start observing Mother Nature a little bit more, but the next step is we need to start respecting Mother Nature a little bit more. There's a lot of things out there going on that we can't even comprehend, that we haven't discovered yet. But the more we back out of it and quit messing with things, the stronger system we're going to build. So now this is where I feel like we are now. You see the soil primers is a big part. It's all about adding the life back in the soil, and we've really created a strong system now. The one thing I haven't touched on too much just yet is diversity, and I want to dive into that one a lot more, because that was something that kind of came on along a little bit later. And I'll have to give Jay Fuhrer a lot of credit for that one. When we first went to the green manure crop, we were doing a potato Sudan grass rotation. And I was really proud of myself. We were seeing a lot of benefit from that Sudan grass those first couple of years, because we brought in diversity, because it was a new crop out that our soils hadn't seen before. We saw a lot of benefit. But Jay told me, he said, well, the trouble is you're eventually going to get stuck in this rut where the potato Sudan grass kind of plateaus out, you don't see any more benefit anymore. So he started telling me about the multi-species green manure mix. So we wanted to pursue that a little bit more. So this was the mixture we planted 2 years ago. So you can see we had 10 species out there. It was a really good mix. You can see a picture of the seed down there and then what the plants look like coming up. This year I altered it a little bit because I also wanted to try to bring in some livestock onto the field. In that original mix I had some Sudan in there. We didn't want to worry about freezing it, having prussic acid, all those problems. So we changed it just a little bit. So we actually went on the Green Cover Seeds site. They've got a cover crop calculator on there, which is a really good tool for figuring out these mixes. One thing to keep in mind, I think a lot of times people think, well, I just need diversity, let's just rank 10 random species and throw them out there. But there is a thought process that goes into designing these mixes here. There's always 4 categories you want to make sure you're covering, because that's the only way to have true diversity out there. And that's the cool season broadleaves, cool season grasses, warm season broadleaves, and the warm season grasses. So when you look at our 10 species mix from 2 years ago, this is how they broke down into these 4 categories. You see we've got each of those 4 categories covered. But there's another thing we always want to have a strong emphasis on, and that's legumes. So we had 2 legumes in this one, and this last year we actually ended up adding the 3rd one. So now you can see where we're truly starting to get some diversity out there. Now I always like to change my mix up just a little bit each year, just to keep things kind of shaken up. We call it organized chaos around our place. You always want to keep things a little bit randomized, but still stick to this. And there's always certain species that we've kind of discovered as we've gone along that I really like as my foundation out there. That's because they all serve a very specific purpose. The buckwheat's really important in our mixture. I'll probably never get away from that one because we have a lot of phosphorus in our soil. The trouble is a lot of it's tied up, it's very immobile. By bringing that buckwheat in, it's got an acidic root, does a really good job of bringing up that phosphorus, and we've seen a huge difference in our soil samples on the phosphorus by bringing buckwheat in there. Now I was talking about the flowers that attract predators. So how great is this? We've got our field split in half, and on one half of the field we got all this buckwheat out there to attract all these predatory insects right next to our potato crop. So that was another benefit we really like from having all the flowers out there. We know we're attracting predators out there, a lot of different insects, pollinators, because we always have a neighbor that's trying to grow canola. So for hybrid canola production, they have to bring bees into their corners so they do all the pollinating for them. But what happens is all the bees come over and start hanging out in our buckwheat instead of doing their job out in canola. So you walk out in our field now and it's just alive. That field is just buzzing. It's really a cool thing to experience. The radishes and turnips are a huge thing. They've actually helped us eliminate one of our tillage practices. Most guys out in the valley, after we're done with potato production, you tend to get a lot of compaction out in the soil because there's a lot of heavy equipment out there and would compact that soil out there. But what we do now is after potato harvest, we don't do any field work out there. We just leave it alone, and the next year we come in with this green manure mix. Those radishes and turnips have a great deep taproot, and they're doing the tillage for us now. So we're letting the life do the tillage for us. Instead of us going through, ripping up that soil, destroying soil structure, and burning fossil fuels in the process, we're letting Mother Nature do our tillage for us. The other thing that's nice is the radishes and turnips have a real deep taproot. So they can go down and find nitrogen that's been reached past the root zone of that potato crop, bring it back up, put it in that tuber. When it freezes, breaks down the next season. Now we've got all that nitrogen up top, working to utilize it next year. So a lot of these little things have added up and really had this huge impact on our nutrient cycling that I was talking about. The other thing that's nice is the radish and turnips have a big broad leaf that puts out real early, so it's really good for helping control weed populations in our multi-species mix. The lentils and peas, nitrogen fixers, because they're both legumes. That one's pretty straightforward. I said we were using the Sudan grass because it's known for its nematode suppression, but now we're completely on top of that. We don't really like that one out there for the grazing, so we've switched to 2 different species of millet out there. So when I used to think about, I think most farmers understand the value of rotation. I used to think, well, I can see the value of having 10 different crops out there. I used to think it would take 10 different years to accomplish that. But what's really nice is when you start bringing all this stuff in together, instead of just getting the benefit of one of those at a time, when you plant them all out there the exact same year, you're getting the benefit of each of those every single year. So once we went to this diverse mix, that's when we really started making progress. We're really seeing great things happen out in our soil. The other thing that was really nice about the green manures too, is just on a little side note, is just it's been fun for them. And I think we don't bring fun back in farming enough anymore. This was the very first multi-species green manure I ever grew. There was stuff popping out there that I knew I'd never seen before because we'd never planted it before. We know we went from this potato and grain rotation. You knew what was like it was more, and I got tired of it. Now I had all this different life out there. So I had stuff popping up. I had no clue what it was. And through process of elimination, I was able to figure out what quite a few of them were. And I got to this one plant, never seen it before, and I called up Ray Archuleta. I was like, hey Ray, I got this plant out here. I need some help identifying it. I want to know what it is. I said, it's got to be buckwheat from what I can figure, is that's the only thing that's I haven't seen on my list. So I said, describe buckwheat plants to me. He was trying to describe it. He did a horrible job. I couldn't figure out what he was talking about. He goes, shoot, Brendan, he said, hop online and Google it. That's what I did. I went into Google and typed it in. I was laughing so hard at the field when I saw that kid pop up. I said, well, serves me right to type in buckwheat. So lesson to be learned here, when you're Googling plants, type in buckwheat plant. That picture changes completely. So by seeing that, though, I was able to identify it. But of course, here's how my brain works. I thought, well, that was pretty darn fun. I said, I wonder what would have happened if I put alfalfa. Then I was sitting there, I was like, what's going on here? Buckwheat and alfalfa. What is the connection here with multi-species green manures and the Little Rascals? But think about it. For those, remember the Little Rascals? Each of these kids was funny in their own way, right? If the show was just one of these kids all by themselves, would it be very funny? Probably not. When were they funny? When you brought them together and you're allowed to see their personalities interact with each other. That's what made the Little Rascals so special. So I think it's a great analogy looking forward to diversity. So after we grow the green manure crop, this is what we do with it. So like I said, we're not no-till. This is the one tillage we do every other year on our farm. When the green manure is standing, we go ahead and spread our compost or other inputs out on top of that. We go through the choppers. We want to break down that residue a little bit. And then we go through with one pass just to get some good soil contact with this residue. Now I understand that the value of the residue on top, I talked about having that armor on there. But the thing that's different for us is we're potato growers. And I've tried some different things out there, leaving more residue on top. And when you go through the next spring trying to row out, planting, you just have a royal mess. So for me, I have to break down this residue. I'm managing my residue. I've got to get rid of it because to a potato farm, it's not residue anymore. It becomes trash. So I understand the value of the no-till deal, but I said I haven't gotten there. So one thing that's really been nice about it though, so what we've got here is on the right here is after we made that one pass with the sunflower, did a really good job of removing a lot of stuff out there. But you see the radishes that are still out there? Those radishes were so deep it never terminated them. They kind of just got transplanted, ended up in the same spot there. The frost comes in, kills off all your warm season crops, and what was really nice about it is we gave those radishes a whole another month to grow. So now instead of that taproot that was like that, now we're getting those monsters you keep seeing. And we didn't have to add any more irrigation to it. It was very efficient on its water use. So I feel like I'm getting a little extra benefit from that now. So now we wait until after potato harvest, we go back through real shallow with a disc just to terminate that crop, and then I row out. So if you were to go back to my place right now, I've got potato rows made. I'm ready to go the next spring. Everything's been put to bed. And the next time I'm in my field, it'll be to plant potatoes. So there was something still bugging me though, as we keep talking about this diversity thing. I saw a tremendous value for bringing diversity out in the green manure mix. And when you look back at our farm, the operation we used to have, we were potatoes and barley. I mean, you couldn't get much less diversity out there. Brought in the Sudan initially, gave us a little diversity, we shook it up a little bit. Then we started really getting serious about it. We had a 7-species mix that first year. Kind of really surprised us just how much benefit we saw from that. Had the 10-species mix the next year, and ended up with our grazing mix this year. But when you look at that, we had great diversity on one side of the road, and on the other side we still had the sad, lonely potato all by itself. And I really wanted to figure out some way to bring in some diversity in that potato crop as well, because I thought there was a lot we could gain from that. So I had one of those aha moments one day when I was out roading potatoes. And what I mean by that is we walk our potato fields and we pull plants that have noses. We have to meet certain tolerances there. We used to grow field peas a long time ago. When I was going along, I'd always pull a weed here and there, just cleaning things up. There was a pea there, and I went and pulled it. I thought, it's not doing any harm. So I kept walking, and I stopped. I thought, well, you dummy. That plant's not doing any harm. Maybe it's actually doing me some good. So I really started stopping and thinking about that. You know, here it is, a legume. It's going to be fixing nitrogen for me. It's a diverse root system. Diversity is good as far as root system. Each root system is going to feed something else in the soil. It's flowering, so it's going to be attracting predators. But you know, this may not be too bad of an idea. So the very next year, there we were planting potatoes. I had a 5-gallon bucket of peas that I got from the neighbor there. And we just hopped on the back of the planter, split the bucket in half. Me and my brother sat there, and we just spoon-fed peas down where the cups were going. My brother was sitting there, what are we doing? How much do you need? I don't know, just do it. We were carrying the cat by the tail. That's what we were doing. So I liked it so much. So here's a picture from that first crop we had. I mean, the peas and potatoes just really went well together. Well, I said, well, duh. I mean, everybody knows potatoes and peas. You know? So that made a lot of sense. So I liked it so much, I thought, there's no way I'm going to sit back here all of potato or plant the next year and plant my own peas. So we designed a potato planter to do the job for us. So what we did is we took a couple of Gandy boxes there, and the hoses feed right down into the trough there where the potato plant is getting seeded. So now we plant peas with every acre we grow. Of course, if you haven't figured this out by now, we aren't satisfied very easily. So I saw a lot of good from the peas, and so now I had 2 species out there. Well, that's okay, but I wanted more out there. So now we plant chickling vetch as well. The reason I picked chickling vetch, if you guys aren't familiar with it, it's another legume, so more nitrogen fixing potential. Also, the reason, you think, well, they're both legumes, you're not getting any extra benefit out of it, but it's still 2 different species. They're releasing different exudates in that soil, so it's still changing the diversity in your soil. So one thing at first when we started planting these, I planted the same depth as the potato seed piece, and one of my concerns was I hope these peas and chicken vetch can make it up. That's why I chose pretty large seed. So we're going pretty deep with those things. And I was pretty worried that they would come up at all. The problem we're actually having is the peas and chicken vetch are actually beating the potatoes out of the ground. So we go through and rodweed. So a lot of times when we're rodweeding, what happens when you have a potato with a spot out like that, we go through and take the top of that peel off for weed control. So a lot of times now I've got peas and chicken vetch popping up while I'm rodweeding. The first year I did it, I saw that happen, and I thought, the companion cropping was a nice thought. I guess we'll wipe it out, so I'm not going to screw up my potato crop in order to do it. But what's really nice is with peas and the chickling vetch is when you knock the tops of those off, it just goes down to the next node and sends up another shoot. So another reason I like them, I played around a little bit with pinto beans too. The pinto bean pushes up that cotyledon. You knock that top off and it's done. So I really like those 2 species out there. So now you can see when our potatoes start popping up, now you can see the peas and the chickling vetch coming up here right along with the potato crop. And I tell you, it looks really nice out there. So when back home, I started telling some guys what I was doing out there, and they thought, man, you're going to put competition out there. You don't want more plants out there. All you want is the crop you're growing. If you put anything else out there, you're creating competition. And we've really got to get past that. Diversity isn't competition when it's done in balance. What it is collaboration. So what you can see here is, so now instead of having a strip out there with the peas, now I left a strip out there without the peas. So you see that line there? So there's the peas on one half and nothing on the other half. What's really nice with those peas is they climb that potato plant. So once they get a certain height above that potato plant, they kind of fall back over. The 2 really have a nice balance together. Nothing really overwhelms the other one, so it's really nice. The first crop I ever planted, that companion out there, the neighbor had to come by and see my planter out there as he's wondering what in the world we were up to. I said, I'm planting peas out my potatoes. He said, man, that's going to look horrible. So we had a field day. We had a soil health tour out at our place, and he happened to show up, which I was pretty pleased with. And I asked him, I said, hey, where's John? Oh, I'm here. I said, hey, you remember how you told me this field would look so ugly? He said, yeah. I said, well, what do you think now? I said, I think it's beautiful. I got to agree with him. It's just so nice. You got to change your mindset a little bit when you start heading down this path. We've been trained in agriculture to look for monocultures. That's the crop I planted. That's all I want to see out there. We've got to get away from that. Out in nature, diversity exists for a reason. The plants help each other out. So now I'm disappointed when I only see the potato crop out there. I like to see other things growing, and just look how pretty they look out there. So that blue flower there is the chickling vetch. Now the white flower there, look what I got there. I was so happy with what the buckwheat was doing out in my green manure crop. It was so far from a lot of my potatoes. I thought, I've got to intensify my flour production out in my potato crop to really focus on this predatory issue. So now I throw some buckwheat out there as well. So some guys drive by and they see all these different plants flopping up out there, like, oh, you really screwed up on your weed control this year. Like, yeah, maybe someday I'll learn, right? So now these are some of the nodules we're getting off our peas. We're fixing nitrogen. And here's one thing I thought was pretty exciting. So Chris Nichols, I'm sure most of you guys probably know that name. She was in Colorado right when I was doing this, and I asked her, I said, hey, I'm doing this thing with peas and potatoes out there, and I said, I got this question for you. You got peas out there, they're forming nodules, I know they're fixing nitrogen. At what point am I going to get the benefit of that nitrogen? Is it down the road? Is it next season? I don't really care. I'm still fixing nitrogen. Even if it was next season, I'm still okay with it. I'm still going to pursue it. And she said there was a lot of research out there being done with legumes and grasses. What they were discovering is the mycorrhizal fungi in the soil was attaching the two plants together when it was able to transport the nutrient from the legume straight to the grass. She felt like we were going to see the same interaction in our field. And wherever we planted those strips that very first year, we did see a yield bump in each of those. So I think we are getting direct impact during that growing season. But then there's a couple of things that have come along that you just don't really anticipate. And that, like I said, that's part of what's fun here, is kind of rediscovering some things. The peas went to full maturity there, and a lot of people ask, well, how are you going to harvest that pea crop? I said, I'm not really worried about it. I'm not producing it for a crop. It's serving a different purpose. But what's nice, I had those peas out there, and at harvest time, they got shattered and they got planted. So right in the earlier potatoes that were harvested, as long as the conditions were right, I actually got a new crop of peas coming up. Now this is after they froze off, but this was the very next year. So what's nice is, ND-SWCS gives me a lot of crap about potatoes out there, is it's a low residue crop. I don't have that residue out there. But now look, now I've got peas growing right after my potato crop. I didn't have to pay for that pea crop. It was free, holding my soil down in the spring, which is our highly erodible season, in a low residue crop. How nice is that? So now look at where we are as far as diversity. Now I'm growing all these different species just to grow one potato crop. And to be honest with you, I'm not content yet. I don't feel like we've got enough diversity out there yet. So we're going to keep pushing the limits and trying to get more out there. A lot of people will tell you that you need at least 30 species in a system to have true diversity out there. So I'm only halfway there. So we've pretty much covered all these here as far as why I'm doing the companion crop. So you see when we bring in the companion crop here now, what's really nice is it strengthens the system even further. Now you've got more life out there. Every time you add more life, it makes the structure even stronger. It's having an impact on our fertility, our nutrient cycling, the life in the soil, the carbon, and the predatory insects now. I think it's interesting, though, as you start thinking about these new ideas, it's just I think we're giving ourselves a little too much credit sometimes. I was really proud of myself. Peas as a companion crop and potatoes. I bet nobody's ever thought of that before, right? Well, you look in some of these gardening charts for companion cropping. Look what it says with potatoes. Dang it, peas. Just kind of embarrassed. We've been walking around with our blinders on. Open your eyes. So I thought, well, that's probably the only chart out there. So the very next one I found, dang it. Peas and potatoes. Man, I was kind of embarrassed. I didn't see any of them recommending buckwheat out there. I'm pretty proud of that one. So I always have my camera, my phone with me. I took a picture of every insect I could find out there. So what was interesting about it when you go back and look at the pictures is almost every single one of them, all the pictures I took of the predators out there was always on the buckwheat flower out in the potato crop. So ladybugs, great predator aphid. We've always known that one. So then I'd start taking these other pictures and I had to send them off to my entomology so I didn't get them identified. And this one here, some fly at the top, it's a cobalt beetle at the bottom there. Another predator aphid. This one here, never seen before in my life. And I don't know if he's never been in my field before or if I just never noticed him before. Checkered beetle. Guess what? Predator aphid. How cool is that? This one here, I thought, oh, surely that's got to be an aphid-eating machine, right? No, stink bug, not a predator. So that's okay, it's still diverse life. That guy's doing something for me out there. Every living component has a role out there. So more diversity, I don't care if you can identify what it's doing for you or not, diversity is always better. So here's another true bug, not a predator, but that's okay. Another fly. Saw a lot of these guys out there. We always had a ton of these. I forget what this one was called. But this one kind of surprised me a little. Found a spider out there. Made a web right on the potato leaf. You know that guy's out there eating some other bugs for me. So that one really surprised me. And this one here scared me just a little bit. I was surprised I even got a picture of it. Big old nasty looking blob. I didn't stop and ask if it was eating any insects or not. I was pretty excited. So I snapped a picture and moved on. Then this last one here, that one was really cool. You guys know what that guy is? Green lace ring. Another predator aphid. I've never seen one in my potato field before. And I think the whole reason why I've never seen one out there before is because the one thing I was missing was the flowers. Now that I've got flowers out there, look at all the life that I'm now supporting in that system. So when the more diverse life out there you have, the less room you have for a pest to come in and overrun your crop. So now when you get back to this nice healthy system, we've got all these different components in there. I always like to go back and look at them side by side. And like I said, it's interesting to look at how we used to farm and how much we were damaging ourselves. You know, we were creating all the problems ourselves. And like I said, I like to define them as probiotic and antibiotic. It's interesting when you look up the definitions of these, because antibiotic, that's exactly how it's defined in the dictionary, tending to prevent, inhibit, or destroy life. I think that's a very true definition of what's going on in agriculture. So now you look at probiotic, I didn't really care for the definition in the dictionary, it didn't really apply, so all I did is took that one and flipped it around. Tending to promote, enhance, and nurture life. That's what we're trying to accomplish now. So as we move forward with this probiotic system, people keep asking, well, how do you know what you're doing is working? Well, I've mentioned a lot of things, you know, water consumption, our fertility, the economics behind it. You keep noticing these other things that kind of surprise you along the way. So what we've got here is some red potatoes we grew off on that side. And this was up on top of our harvester. You know what these are on the left? That's the seed piece. I dare you to go in that valley and find another seed piece that looks like that. Most of the time when you have that unhealthy soil, that seed piece it decays in the soil, it becomes a little snot ball. But now we're to the point we actually have to harvest, we have to sort out our original seed pieces at harvest time. That's how healthy they're coming out of that field. They're still nice and firm, they have a lot of vigor and life to them. Another little thing to really keep an eye on is the soil around the root. When we used to pull that seed piece up and have those roots out there, the roots would come out of the soil very clean. That's because it wasn't supporting the life around that rhizosphere. Now that you have that life around that root, you're starting to create those soil aggregates. There's getting that sticky substance in there holding that soil together. So that's another one of these small indicators that we really need to pay attention to. You know what this one represents? It's something very important. One of those observations, I didn't know how to visually describe it, but the smell of my soil. So that picture is of the smell. That's one thing we really noticed as our soil started to heal. It's just how the soil smells. I'm sure you could talk about this one a lot too. Just you can tell by smelling the soil if it's healthy or not. Now our soil is nice and sweet, has a very pleasant smell. A lot of times that's associated with high actinomyces activity. So that slide there is for smell. So anybody wants to take a picture of that one, I can email you that slide. So now, here's the system we have. I'm still not satisfied, so I'm still trying to find more and more ways to bring life into the system. So this is my next goal. Like I said, I had my green manure mix designed for grazing this year. I thought I had it all set up to bring cattle out there to graze that green manure. We had a couple of things fall apart on us at the end. I wasn't able to get those cows out there. And once again, a lot of this, I'll give Jay a lot of credit on this one. But there's a lot of benefit by bringing the cattle in there too. And like I said, it's all about bringing more life into the system. So I think I've got another guy lined up this year. I'll do another grazing mix and hopefully I can get some cattle out there. But once again, I probably won't be satisfied with that. So I'll probably want to bring diverse livestock in next. That's what's fun about this approach is you really, you're never content. You always want more and more and more. But there's one more thing we need to keep in mind here. As much life as we've talked about here in the complete picture, there's still one living component we haven't talked about at all today. That's us. I think we're having a huge impact on our crop. I think we've brought more flavor back into our potatoes. I think we're bringing more nutrient back into our potatoes. And I think it's going to have a huge impact on us as well. So I think that's the next step that we need to take, is start tying in the soil health to our health. So I think there's a really strong correlation there. So I'm working with a grad student right now, taking a real strong look at that, trying to take a, see what we can discover there. But I think it's something we need to keep in mind as we move forward. And I've got a lot of personal motivation behind taking care of the soil too. These are my two little girls, they're 10 and 7. So they were out in the field this year with me roguing. And the one in the pink there, you know why she's so excited? You see the smile on her face? You know what she found? Earthworm. Man, she was excited. My kids already understand the value of that life in that soil. And someday, if they want to come back and farm, I'm not going to hand them over some dead soil. I want that soil to be functioning and thriving so they stand the best chance possible. So that's something we need to keep in mind as we move forward. So, but the other thing that's nice too is I love traveling to conferences. I always like meeting the new people around and creating a stronger network as well. So I've got a couple of resources here. We do have a Facebook page for Rocky Farm. So it's a good way to keep in touch with us. When I'm trying to do something crazy out there, I'll put it up there and just get some good conversation going. We need these strong networks so we can communicate together. So we don't have some guy over here doing the same thing as this guy over here. They need to know who each other are. Then the other thing we got going on too is me and Woody here, we formed kind of a consulting business trying to help out some guys that want to take this approach, forming biotic farming systems. So we've created this website. On there we have kind of an interactive form of my presentation today. If you want to dive in, go a little bit deeper. It's a way to contact us too. I'm just trying to put everybody in connection with each other. This is going to take a group effort to solve these problems. So that's all I got for you guys. I guess, you know, I got time for questions. Questions for Brendan?
You came to Maine recently, and
Yeah.
I had to see somewhere else. How did the Maine potato growers in your meeting respond to this? Or did you give them different type of presentation?
Yeah, it was the exact same presentation. Maine was a different crowd. They were excited about it. I think they understood the points I was making, but there was a lot of resistance to change there. Idaho was actually pretty surprised. I went there 2 years ago. I thought they were going to run me out of the rooms. It actually surprised me that Idaho would invite a Colorado boy to pop potato show. So just the fact they invited me, I was pretty impressed with. They actually responded a lot better, and I think they'll be the ones to adopt some of these principles first. So I was a little disappointed in me, but that's all right. I'll keep going back there until we get these guys on board. Yeah. But I see, even back home, the perception of us has greatly changed over the last 20 years too. The way I tell people is people used to refer to us as eccentric. They thought we were doing things just to be different. But now that we've proven it, they see what we're up to, the quality of crop we're producing, all of a sudden we became innovative. We didn't change, but the perception of us has greatly changed. So now the same people that used to sit there and laugh at us are the first ones in line to come and get help from us.
Do you have some of your neighbors that are trying some of the same things you are? Or?
About 4 years ago, I gave a presentation down at our local meeting. Before that, I said, I went in there pretty nervous because I said, we were kind of the laughing stock. People, every time we tried something new, they kind of pointed fingers and laughed at us. But then I went and just put a presentation together and just gave them a full picture of it. And the other thing that was nice is I did an economic analysis of it, compared it to one of my neighbors doing conventional. I think that economical kind of get them right in the gut. That one really grabbed their attention. So right after that, I had a group of, it was 5 or 6 guys that came up to me afterwards and said, you know, the chemicals aren't working anymore. We need help. Can you help us? And that's where we started working with them, and that's kind of what led to what we're doing now with the soil guys. It's just we're getting more and more guys. We're trying to get a little more structure behind this. But what was really nice about it is those guys, that core group that were courageous and took that step forward and started making changes, they saw so much success that now they're the ones going out and promoting the ideas to their neighbors. So now it's all the neighbors that are coming back now, because there's nothing in our area that a neighbor hates more than his neighbor growing a better crop than him. So now he's seeing the success he's having. He's like, I'll be damned if he grows a better crop than me. So we've reached kind of a tipping point in the valley. It's really exciting to be a part of. To where, you know, peer pressure is a big thing. At first, we had a lot of peer pressure against what we were doing. But now we've got enough people on board now. We've got that support network together now. I give it a couple more years, and all of a sudden, it's going to be the cool thing to do. If you're not doing something to improve your soil health, you're going to be the outcast. So I think it's pretty exciting. I think we can get to the same point with the growers up in Maine, too, but they're going to need a little bit more help along the way, a little bit more encouragement. That's a big part of it. That's why I said I'm really trying to help build a strong nationwide network here. We got to be able to rely on ourselves on a lot of this, and we need to help each other out.
You said you're pulling out the seed potatoes from your harvest.
Yeah.
Are you, by chance, able to use them over again, though?
No, I mean,
Just wondering.
I've thought about it. I wondered. I mean, they've lost a lot of energy. That plant pulls a lot of energy out of there. So, I mean, we're not quite at that point. Just there's a lot of physiological things going on there, so not to happen. Yeah, that would be great. Talk about sustainable, but no, we can't do that.
Hi, I was really frantically taking notes, and I think I missed some detail. On your fertility program, what amount of commercial fertility are you applying at this point, or how much have you reduced that?
I've got one circle that has a real sandy soil. It's a yellow phenotype growing out there. I put 10 units of N on that circle. And the reason I do is I use a little bit of kelp. There's a lot of things going on in kelp I really like in potato production. They really help even out the stolons. You get a nice consistent set to it. So I put kelp on everything. This field here, it's a little sandy. It's a little behind my other ones. So I just spike it with a little bit of nitrogen right at the critical time. But it's really not much as far as the foundation of my fertility program. So 10 units on a half circle is all I'm using. The other 2 circles, I don't put any commercial fertilizers whatsoever. No commercial fertilizers, no chemicals.
And you're just at compost every 3
The
quarters?
compost is the foundation of my fertility program. So on the one circle, we're actually skipping the application this year. The other 2, I put a 10.5 per acre. So I'm pretty small now. So I figure I'm putting about 40 units of N from the compost and the 4-H potato crop. So like I said, that really goes to show you. I think we're starting to really discover now, as we move forward, what the true nutrient needs are of a potato crop. It's much, much less than what we've been led to believe in conventional agriculture, because we're really getting more efficient with our use of our nutrients. Plus, I've got legumes in my green manure crop and in my potato crop now. I think that's had a huge impact too. So all these tools we keep discovering, bringing in them all at once. Like I said, somebody used the term silver bullet before too. That's one thing that irritates me. People look at what we're doing. It's like, oh, tell me the one thing I need to do to get here. Good luck. That's why you really have to take the whole system approach. And the thing's nice is we know a lot of different tools that work very well together, but you have to use all of them in unison to truly make an impact.
Brendan, this has been fantastic. I want to thank you for a great presentation. Everyone, let's give Brendan a